The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
And I want to introduce to you Dr. David Pittman. Dr. Pittman is the director of the Geotechnical Structural Branch with the Corps of Engineers in Vicksburg, Mississippi. He actually moderates and supervises over 500 researchers and staff at the center. One thing that's very interesting with Dr. Pittman, which I found very interesting, is that he did his master's and PhD on roller compacted concrete. And I talked to him last couple of weeks ago, and he said, in fact, his first job with the Corps was working on roller compacted concrete. So I think he brings many years of experience and really a great person, a knowledgeable person with the Corps. And I want to introduce to you now, please welcome David Pittman. Dr. Pittman, please.
Well, good afternoon. It is afternoon. Thanks, Wayne, for that introduction. As a matter of fact, I did do my master's and PhD with roller compacted concrete pavements. My master's with Mississippi State and my PhD right here at University of Texas at Austin. And one of my first RCC pavement projects was in the summer of 1984 at Fort Hood, Texas, one of the first major RCC pavement projects in the United States, with Mr. Ron Harris sitting right here in the front. He gave a presentation earlier this morning. So I've had a long history with RCC, helped us come up with the Corps of Engineer design procedures and construction procedures and that sort of thing. And I want to talk to you today very quickly, briefly this morning about RCC and our experience with the Corps. In the last part of the presentation, I want to talk to you about something that Gary Anderton, who actually leads our airfields and pavements branch now in the Geotech Constructors Lab, we sort of simulated a lot of statistics about RCC nationwide in the United States I think you might find kind of interesting. So let me get started. Here's a road map of where I'll take you. I won't belabor the first 4 bullets because everybody's kind of already talked about that, but the RCC applications and trends is what I want to spend a little time on the second half of my briefing. Just a background. Everybody's already said this, but I think that RCC really combines the best of both worlds when you talk about asphalt concrete pavement construction and concrete pavement. It combines the ease of the asphalt concrete paving method with the strength and final properties of Portland cement concrete. So it pulls the best of both worlds. It gives you that final concrete pavement properties in the end. Materials and construction, we've already talked about that a lot. The aggregate, can't overemphasize the need for a quality aggregate. From the very beginning, if you think about on the material side, particularly from the aggregate, from an asphalt concrete perspective, you need something fairly well graded. Crushed, in my opinion, is better. Generally, what you're looking for is something that will hold up under a roller when you're compacting it. That's what's going to govern a lot of your aggregate properties, is how does it handle in the fresh state. Typically a 3/4 inch top size, maybe a 1/2 inch maximum size. You can allow up to 8% fines in it, and that's just to give you a good consistency during construction and help the surface close up. Sometimes you even add fly ash to actually get a little bit more fines in the mix. Talking about the constituents, you might have a little bit less cement and fly ash, a little bit less coarse aggregate, more fine aggregate. Again, it takes that to give that fairly well-graded aggregate mixture in the RCC. Definitely less water, and your water-cement ratio, by definition almost, is going to be pretty low, between, say, 0.25 and 0.35 generally. That leads to very high strengths, by the way. We've already talked about continuous mix and Pugmill plants, and Frank talked about with ready-mix trucks, but typically in the Corps at least, we use Pugmill plants. You see some of the plants we used back in the 1980s. This kind of machine right here in the upper, right there, took a couple of days to get set up and running with a few hundred tons an hour. But now you can get a machine like this that can have you set up and running in a couple of hours and produce several hundred tons an hour. Placing, we've already talked a lot about placing. In the early days, we just modified an asphalt paver, opened up the throat between the hopper and the screed. But these days, when they came along with these high-density screeds, originally built in Germany, and now they're built at other places. But that really revolutionized, in my mind, the way you put down RCC pavements. You get a fairly high-density, fairly uniform material coming out of the screed, and that's going to dictate, that's got everything to do with the quality of the final pavement, is how it's coming out of your machine. And then, of course, we talked about compaction. As Wayne said, that's a very critical point. If you don't get your compaction, you're not going to get your density and strength. And pay that guy right there pretty well, by the way, because he can dictate a lot of the quality of your pavement. If he knows how to operate that roller and get you a smooth surface and a dense surface, then he's well worth his money. We already talked a lot about curing. In the early days, what we did mostly was water moist curing, and here we are in Germany actually on some projects where we use actually irrigation sprinkler systems to keep it just moist all the time. And that's one of the first major lessons we learned at Fort Hood, Texas in July of 1984 on our first major project with the Corps. We talked about hot, dry, windy weather here in Texas all the time. Well, we found out what impact it has on RCC at that Fort Hood project and kind of made a mess of that original project. The surface dried out too quickly. And when the surface dries out too quickly, it crumbles after a few weeks. And so we totally understand that. One of the most important messages here is you got to keep it moist at all times until it gains its strength. So, use whatever method you can to keep a water spray truck to keep it moist until you can get your more permanent curing compound down. But never let that surface dry out until you develop your strength. We already talked about quality control and assurance. Again, very, very important. Probably the most important test is checking your density. Typically with a nuclear density gauge in full transmission mode, you need to drive a hole into the RCC and try to do it through the full depth. And generally we shoot for 98% density or 96%, closer to a joint, similar to asphalt concrete pavement. We already talked about fabricating cylinders. We have smoothness tests. We still use a straight edge in the Corps of Engineers. And we have a little bit looser spec on smoothness with RCC compared to concrete. You can go up to a 1/4 inch off the measuring edge of the straight edge. We talked a little bit about joints and cracks this morning. In the early days, we allowed RCC just to crack naturally because that's what the Canadians were doing. We sort of stole this idea from the Canadians for log sorting yards and that sort of thing in the 1970s. We brought it to the U.S. They weren't sawing joints. We said, hey, why do we need to saw joints? But later on, as we saw the potential of this material, we said, hey, we need to saw joints in this. And so what we do is we try to follow the natural tendency of the material to crack at 10 to 30 plus meters. I mean, the thicker it gets, the further apart the natural cracks will be. I've seen natural cracks occur over 100 feet apart, sometimes 200 feet apart on very thick pavements. So you want to control that, of course, and so you probably want to saw your joints at 10 to 15 meter intervals. Okay, advantages and limitations. We've talked a lot about this already. If you don't have a low construction cost, and typically, I've got some numbers I'm going to show you here in just a minute, an average of about 27% over 30-something projects has been saved from data that we've collected around the United States. So if you don't have that low construction cost, you're probably not going to be looking at RCC, to be honest with you. And it's due to a lot of things. You're putting a lot of concrete down fairly quickly, no reinforcing steel, no forms, less equipment and labor compared to conventional concrete slip form paving, for instance. Ease of construction. A lot of this low construction cost is because it uses existing methods. You just got to find somebody to do this. High strength because of the low water cement ratio and high density. And then Wayne talked this morning about the ability to load it early. That's a very important property. Some limitations. I mean, you're probably not going to use this just anywhere. Smoothness is generally not going to be as good as conventional concrete or asphalt. Surface texture, we talked about managing expectations on that. It looks more like asphalt concrete. Uncontrolled cracking, that's simply if you decide not to saw joints, people need to know you're going to have cracks in it versus a nice saw joint. Raveling, when you don't prepare the surface properly, particularly at joints, you'll have a tendency to ravel. And then the durability, if you test the pre-install durability of RCC in the lab, it will not do very well, probably. But its performance in the field has been phenomenal. I got some pictures here I'll show you here in just a minute. And that worried us a lot, frankly, in the Corps early on, was the durability, but it turned out to be a concern that wasn't realized. So here's the applications and trends I want to speak to you about. Here's that project at Fort Campbell, Kentucky. We actually built this in 1987. I took this photograph, and in 2008, 21 years later, took the same photograph, and it's still performing excellent. At Fort Campbell, Kentucky, by the way, what really hurts the concrete pavement, of course, is the freezing and thawing cycles. It's the number of cycles a year you get, along with moisture. That can really tear your pavement up. They get over 60 cycles a year, okay, little or no damage. This particular project saved 30% over conventional concrete. Here's at Fort Carson, a much more recent project. This was in 2008. Very, very nice job. You can see some longitudinal cracks that are occurring in this one because they pulled that entire width right there, the width of the road, in one shot. And when you do that, sometimes you're going to have a tendency of getting a longitudinal crack in there. That would happen with conventional concrete as well, by the way. So if you want to control that, you'd make a longitudinal cut right up the center of that paving lane there. Here's public sector. The first two I showed you were military applications. The next couple will be public sector, and we've seen a lot on roads, shoulders. This is an I-285 shoulder replacement in Atlanta. Cost about $45 a square meter. Great project. The first use of RCC on an interstate application, it was the shoulder, but I think they were very pleased with that project. Then we started seeing the private sector take off, and as Wayne talked about this morning, the private sector has really dominated with use of RCC in America in the last decade or so. First major one I saw was at Saturn, the Saturn plant in outside of Nashville, Tennessee. Built in 1989, close to 540 square meters. It was a very, very large job. There was a job going on at the same time at Fort Drum, New York. They were competing about having the largest project, I believe. But that sort of kicked off the use in automobile plants. And in the last 15, 20 years, there's been a series of automobile plants built in the southeast, and a lot of them have used RCC for their pavements, for their what we call a light industrial pavement application. This particular job here saved at the Honda plant 30% over asphalt concrete. Most of the cost savings that I report here were actual comparisons of bid costs. So they're comparing apples and apples as much as possible. Here's a slide that Wayne showed earlier, and I'm going to show you a few slides that are a little bit updated from the information that Wayne showed, because Gary and he showed data from a paper we wrote about 4 years ago. We've since updated that with additional data, and a lot of you in this room provided some of that data to us. We assimilated that, and I want to show you some trends that we found out about RCC. Now, this is all the projects. I'm not dreaming that it's all the projects in the United States, but it's probably most of them, a fairly good sum, and it's great to look at trends with RCC. Now we're up to almost 14 million square yards. You can see it's dominated by the private sector. The public sector's really kicked up a lot too, but it's a fraction of what the private sector's done over the last, since, say, 2004 or so. In the military, we were one of the early leaders of RCC, but we kind of flattened out. We haven't put a whole lot down in the last 20 years or so, except that Fort Carson job and a couple other small projects in the last few years. So you can see we're on a fairly high trajectory right there of uses in the United States as people become more familiar with it and more people get experience putting it down. Here's just a summary of the owners. You divide it by private, public, and military. So it just takes that previous graph and says what percentage of the total of each of these. Then we looked at functions of RCC. We used that guide that Wayne talked about earlier that talked about design and construction of RCC pavements. Well, they talk about functional applications, light industrial like that automobile plant, heavy industrial like a port. It's going to be fairly thick. Road, streets, and soldiers, that's pretty much your public use. Logging, compost, and storage is that specialty application on log sorting yards and things like that. And then even airports have used it for storage areas of snow and that sort of thing. This is kind of how it's been used over the decades, the 80s, the 90s, 2000s, and just 2 years into the 2010s. That includes 2010 and 2011. But you can see how we put a lot down in the 80s. In the 90s, we dropped down total production. Then we really picked up in the decade of the 2000s there, and mostly in the light industrial and heavy industrial applications. with the road, streets, and shoulders applications being third. And this year, the last couple of years, we've been on a pace that's going to, if we keep at this pace right here, we'll have 10 million square yards in just this decade. We'll almost double what we did the last decade. Here's where the RCC has been placed. You can see it's been mostly in the southeast because, well, that's just where it's been put down. a lot of the contractors are familiar with it in these areas. It's a lot of good applications. A lot of them, as I said, in Alabama with those automobile plants. But you can see the military has kind of used it all over the United States, and there's a lot of public sector applications. So by region of the United States, south, this is how the census defines the United States in the 4 regions. You can see that the south is placed a lot more than anybody else in the United States. The average area, though, is highest in the Midwest, and that's about 120,000 square meters. In terms of states, here's sort of the top 10 users of RCC by state. Alabama by far with 29 projects, almost 3.7 million square meters. You can see there it's almost about 4.5 million square yards. In Texas is number 2 in this case. So you can see a lot of states, mostly in the south and southeast, but some in other regions of the country as well. This is sort of a busy chart, and it's kind of a summary statistic chart looking at pavement size. So what's the average size of RCC pavements that have been placed in square yards by function? So light industrial, heavy industrial, airfields, road, street, shoulders, log, compost, and storage, and then all pavements combined. You can see on average, the average size of projects that in our database was about 82,000 square yards. A total here of about 13.6 million square yards on 167 projects around the United States. You can see the largest project was about 1 million square yards. Smallest, I think Frank talked about a 50 cubic yard project. That might be that project, Frank. I'm not sure. And then the median is a little bit less than the average usually, because the median, of course, is that value at which half the projects are larger than that and half are smaller than that. So you see we got a lot of smaller projects in this mix all the way across. Now we look at thickness and looking at inches. Same sort of setup on the application here. On average, for all the projects we've seen, an average of 9 inches, with the heavy industrial, as you might guess, being the thickest. Light industrial being about 7 inches, the thinnest, and numbers in between here for the other applications. 215 projects. The reason there's more projects here than the previous slide is that some of the projects as recorded were multiple thicknesses. So we tried to break them down by size relative to thickness. And then here's the cost data. We were able to collect this data this is kind of hard to get because most people, they don't necessarily bid both types of, like RCC against conventional concrete or asphalt, but if they do and they'll share them with us, that's exactly what we want. So this gives you same sort of data for 21 projects that reported it, cost savings, 38 projects that gave us cost data. Some of those gave us the actual savings against another project. But here's the range of costs, and I think Wayne said it this morning. You know, the cost is pretty much driven by the size of the project, typically, all other things being equal. But it can vary all over the place. As you can see here, dollars per square yard from 9 to a factor of 10 higher than that. They can vary for a lot of reasons. And these aren't adjusted, by the way, for inflation, so these are the actual costs that are reported whenever it's placed. But you can see a fairly wide range, but typically we're looking at $35 a square yard, something like that, average. And cost savings ranging from 9 to 58%. An average, though, of 27%. And we've said for years that an average cost savings of about 25% is typical for RCC, and that's sort of proved out. So this is my last slide. In summary, we think RCC's got a very bright future, and we've been saying that for a long time, but I think it's justified looking at the data. That it's exploding out there, and as more folks like you have more interest in this and want to try it, there's a base of knowledge out there that's growing and experience that can really help you out. And I think everybody who's going to talk up here today is interested in you being successful, because we all like RCC and want to see a lot of it go down. There's going to be a lot more demand with time. The infrastructure is not getting better. We've got to find cost-effective ways of replacing that infrastructure. and I think it's going to be around for a long time. So with that, I'm going to wrap up, turn it over to Wayne. Thank you.